Hello everyone. Today in this lab we're going to work on RL, RC and RLC circuits. Just for time saving, I'm going to focus only on one circuit, and the other types they could be easily performed. You just follow the word file. Just follow the steps. So let's say we have an AC voltage source. So far we have been using DC supplies. Now this is going to be our AC source, and we have a resistor and there's a capacitor. So that's an RC circuit. And in the last tutorial I showed you how to change the title of the circuit and to add a text annotation in the circuit. And this one, actually this is part 2. So the part 1 will be RL circuits. So let's say I want to investigate the circuit. I want to find the voltage drop on R1 and C1, the resistor and the capacitor, and I want also to find the current that passes through the circuit. So let's start by just looking at the voltage and see how this one is different from what we had so far in DC supplies. So we have the circuit here, and let's just run it, and you see that the value of the voltage is fluctuating, basically because my input is an AC signal, and AC signal varies over time. So here the voltage here will not be shown. So we need to add another setup in this sensor here. As an easy setup, you just click here on the sensor type and you click to your right. See the settings one, this wheel, click on the settings. Now, usually the measurements is instantaneous. So whatever the voltage is, it will show with respect to time. So here as long as the time goes, the voltage will be changing. So that's why it's instantaneous. So we just want to change the display. We don't want instantaneous. We want periodic. So periodic shows at one period. It gives me information about the peak value and other information. So let's move this instantaneous and have periodic. And we have a lot of information here. And these information are peak to peak voltage, RMS value, VAV, that's the average, and the frequency. So the frequency is 50 Hertz. That's basically the same input frequency. Now, just run the code again. Oh, sorry, not the code. Run the simulation again, and notice like these values are constant. They do not change because I'm running it on one cycle. And even this VAV, the average, like it's in micros and millis, so it's as good as 0. So the value here of interest is the RMS value. Actually, there is a relationship between RMS and peak value. Is you just, whatever you have here in the RMS, you just multiply it by square 2, by the square of 2, and you'll get the peak value, and that's the value we seek. So basically, if you are given this circuit and you want to solve it in the exam, so far we have been working only with peak values. Now, when usually in AC analysis, we deal with RMS values. So the only difference is just you have to scale the value in the simulation by multiplying the RMS by square root of 2. And that's it. That's the only setup you need to do for measuring AC voltages and currents also. Similar thing here. I want to measure the current, and let's assume I want to put the current here. Now notice here, like the current's always pointing to the right side. What if I want the current to point to the other direction? So you go here at the settings, flip current measurements. So notice once I click this one, how this arrow will change direction. There you go. So I'm like my current will be going from right to left. And again, I want to do the setup, so it's not instantaneous, make it periodic. And again, run the simulation. And again, RMS is constant current, constant value, it does not change. So in order to get the current, you multiply the value of the RMS by square root of 2. And similar thing we will do for the capacitor. Voltage, add a reference, and we'll do the setup periodic, remove instantaneous, run the simulation, and you will get the values here. So this is it actually, the main difference between DC and AC. In DC, everything like is straightforward. I don't have to add another setup. In this one here, you have to, in the probe measurements for voltages and currents, you have to add an extra step because we are dealing with AC signals and their values change with time. So this is the only, let's say, additional step that you have to do. Now let's look at the handout. So basically, yeah, in order, let's say for the theory, just refer to the lecture notes of RLC circuits that we have done. I believe that was chapter 5 or 6. So for the required equipment, we need an AC supply, 1 resistor, 1 inductor, and 1 capacitor, and we need the measurement tools. So the first part is the RL circuit. So we have the circuit here. I'm having an AC supply, resistor, and inductor. And by the way, like usually these schematics, they don't have the ground, but whenever we do simulation, we have to point the ground. So here is the ground here. So you must have, this ground will be in every circuit, whether it was AC, DC, and so on. There'll always, let's say, a need for a point of reference. Okay, so we have the components, and I believe everybody knows how to change the values. You just double click on the component. It will open, say, the properties. You change the voltages, frequency, that's for the supply, the AC supply, capacitor, you change the value, resistor, and so on. So do the changes here. And then the first part, you have to solve the circuit as if you don't have simulation tools. You just need to solve it. Just imagine this question, you faced it in the exam, how are you going to solve it? And in Microsoft Word, it's easy to write formulas and equations. You just here insert equation, and you can proceed and write your own formulas. Okay, so Control Z. So the first part, you need to find the inductor reactance. If you forgot the formula, refer to the handouts. The total impedance of the RL circuit, the current that passes through the circuit, and you need to find the voltage drop at each component. So these requirements, you can confirm their values with the simulation. Again, this one here, you just find the peak values. You don't have to do any extra steps. Now use the measurement tools, and yeah, check this tutorial, find the voltage drop at each component. Now the measurement tools will give the RMS value. Just multiply it with the square root to get the peak values, and you can relate that the values between the simulation and theoretical, they should be identical. So this is the first part for RL circuits. Similarly, we'll do the same thing for an RC circuit, AC supply, resistor, capacitor, and here are the values. So again, solve the circuit analytically as if you don't have any simulation tools. Use the equation tools in Microsoft Word, and then use the measurement tools on the software. And the last question, we have the full story here, RLC circuit. Keep in mind that there is some, it's not straight addition between the inductor and the capacitor. So I encourage you to go back and visit the lecture handouts. So here are the values, solve it, and do the simulation and compare the values. And actually that's it. The experiments seem to be long, but it's quite easy. It's a very easy one. And in the last part, you just need to do some conclusions. So yeah, I'll put a heading here for conclusions. And in the conclusions, yeah, just compare what you did in theory with the simulation and see like if there are any differences. So yeah, that's it. As I mentioned, that this tutorial is going to be short. And yeah, if you have any questions, feel free to send me an email.